Alright, y'all. We might do a quiz on Monday now. Things have changed since I'm not here again today. Hudson has croup. I don't even know if that's how you say it, but that's what it is. You still will have your test on Tuesday, so Monday will be a review day. We might take the quiz right before your review. Okay, so if you'll have any questions, feel free to, you can message me on Remind, okay? So if y'all are super stuck today, I will post this video on my website if you need to write it down. Okay, bit.ly/Cumberledge. Remember, this is all lowercase. Okay, so write that down if you need it. Okay, so we're going to jump into the lesson. I'm going to go over some problems with y'all, go over some questions, go over some problems, and then you will try some problems on your own. So this is the last page in our packet. But first I want to go over a couple things. So reminders, what are inequalities? So remember, inequalities are kind of like equations, but instead of using equal sign, you use these signs, okay? A trick I always tell y'all is your left hand makes your less than sign, so less. Okay, your left hand makes the less than sign. So this is less. It also makes the word less. Okay, this is greater. Okay, then this is less than or equal to, greater than or equal to. Okay, when do you flip the inequality symbol? Remember, when you multiply or divide by a negative. If you need to write any of this down, you can write it on the front of your packet. Okay, so when do you flip the inequality symbol? When you multiply or divide by a negative. If you subtract, you do not have to flip your symbol. Okay, what symbols go with an open dot? Okay, so remember, anytime you have an open dot, it's just less than or greater than. That's not including, it's exclusive, so it does not include. Okay, what symbols go to the closed dot? Is your equal to, because they include that as your solution. That is equal to, okay? Okay, one more thing I want to discuss with you. I'll write it on the paper though. Okay, so remember, open dot is less than or greater than. Closed dot is less than or equal to, greater than or equal to. Okay, so we're still solving absolute values, except now we're solving absolute value inequalities, so no equal signs. Okay, so your rules still kind of apply, there's just one difference. So you should have your notes on how to do this. So remember, your first rule is to get your absolute value bars by themselves on one side of your inequality. Okay, so this is by itself. My answer is positive, so I keep going. Okay, I'm going to separate it without the absolute value bars. So I have negative 2x is less than 2, and I have negative 2x. So here's the different part. You have to flip the symbol and make it opposite. So it was positive, flip it, make it negative. Okay. Okay, so flip it, make it negative. So now we solve our inequalities. So here, we divide by negative 2, divide by negative 2. Well, right away, we just talked about this. What do we do when we divide by a negative? We flip our symbol, okay, because we divided by the negative. So our symbol's now going to open that way. These cancel, and I'm left with x. 2 divided by negative 2 is negative 1. So x is greater than negative 1. There's my first inequality. Okay. So then I do this one. So again, divide by negative 2, divide by negative 2. So again, we're going to flip. Okay. So our symbol's now going to go that way. That cancels, and I'm left with x is less than positive 1, because 2 negatives makes a positive. Okay. So one thing I want to show you is that this is the less than sign. So if you write than, it's super easy to make the word and, which means it's between the two. They're both, okay, so this is what I'm going to show you. These are both going to be open dots. So if we made this solution on a number line, okay, remember your smallest one goes first. Okay, it says x is greater than -1, so we know we're going to go to the right, and x is less than 1, so we know we're going to go to the left. So it can only be between -1 and 1. Okay, it can only be between -1 and 1. So the way we write that as an inequality, because remember we're dealing with inequalities, is -1 is less than x, because that's what we solve for, is less than 1. Okay, these are always going to be less than symbols when it's and. Okay, always less than symbols. It goes inside the fancy brackets. Okay, because they're open dots, they will be no equal to. Okay, so there is your first solution. So remember, the big things that are different, so when we write our second equation, we flip it and make it an opposite. So it was positive, now it's negative, and we flipped our symbol. So opposite, 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 opposite. Okay, and then we have our number, we build our number line and write it as an inequality. So let's do another example. If you notice, this is greater. So greater. So this is going to be two kind of different solutions versus one connected solution. So let's do, the absolute value bars are by themselves, so we can go ahead and separate. We have x, drop our absolute value bars, is greater than or equal to 2. Now we do opposite, opposite, so x plus 5 is less than or equal to -2. And now we solve. So here we're going to, how do you get rid of a plus 5? You do the opposite, so we're going to do -5, -5. So 5 minus 5 is 0, and we're left with x is greater than or equal to 2 minus 5, which is -3. Okay. I'll do it again. Same step, -5 minus 5, and we get x is less than or equal to -7. Okay, so I want you to realize that when we build this on a number line, remember smallest number first, which is technically -7. Now, will these be closed dot or open dots? So it's equal to, so these will be closed. Now, if x is greater than or equal to -3, greater than is going to be this way. If x is less than or equal to -7, it's going to be less is to the left. It's going to be that way. So you see what I mean is or, it's going to be less than -7 or greater than -3. So we're going to write that just like that. So x is less than or equal to -7, or x is greater than or equal to -3. So that is that answer. Okay, so that's the difference between our and our or. Okay. So really number 3 and 4, I'm just going to help you get started. Okay, so remember our first rule is to get our absolute value bars by itself. The 6 is not inside the absolute value bars. So this means absolute value of 8x plus 4 divided by 6 is less than 10. So we know it's than, which means it's going to look something like this. Okay, so how do we get rid of a divide by 6? Well, the opposite of divide is multiply. So we're going to multiply both sides by 6, because remember, what you do to one side, you have to do the other. So these 6 cancels, and I'm left with absolute value of 8x plus 4 is less than 10 times 6, which is 60. So now I can separate. It's less than 60, opposite, opposite, the second time, 8x plus 4 is greater than -60. Okay. So now we solve. So first things first, we have to get rid of addition or subtraction first. So I'm going to do -4 minus 4. That goes away. I'm left with 8x is less than, what's 60 minus 4 is 56. Okay, then I'll divide both sides by 8. Give you a second to get that down. Okay, so this gives us x is less than 7. So now let's solve the other one. Same steps, except we're going to get a different number on the right. So minus 4, and that leaves me with 8x is greater than negative 60 minus 4, which is negative 64. Okay, and so when I divide both sides by 8, I get x is greater than 8, because negative 8, sorry. Negative 64 divided by 8 is negative 8. Okay, so build my bar. Negative 8 is my smaller number. These are not equal to, so they're going to be open dot. Okay, and now we said this is and, so I should be between, but let's think about it. If x is greater than negative 8, that does go to the right, and if x is less than 7, that does go to the left, so it works out. So our answer is going to look like this. Smallest number is less than x is less than 7. Okay, no equal to's because there were no equal to's, they're open dots. Now if you notice, see how the mouth here with the negative 8 is eating the x? It's still eating the x if I look at it just one piece at a time. Okay, the mouth here is eating the 7. It's still eating the 7 if I look at it one piece at a time. Okay. So number 4, we're just going to literally get it started. I said that about number 3, but I just kept going. Okay, so how do you get rid, first remember we have to get our absolute value bars by themselves. How do we get rid of a multiply by 6? So we're going to divide by 6. Do not distribute. That cancels. We're left with absolute value bar 2x plus 5 is greater than 11. Okay? So knowing that, you should be able to solve just like those up here. Remember, this is a gray tour. So it's going to look something like this one. Okay? Now let's look at 5 and 6. And these are a little different, and I'm going to show you something in just a second to kind of pull on your old knowledge. But let's work it out. Okay, so here, I have to get my absolute value bars by themselves, so I need to divide by negative 8. Okay, negative 8 divided by negative 8 cancels. I'm left with the absolute value bar of x plus 4 is greater than, oh, nope, I need to flip. Why do I need to flip? I'm glad I caught myself. Because I divided by a negative. Okay, so this should be this way. So 48, make sure you fix yours if you did what I did. Okay, so 48 divided by negative 8 is negative 6. So one thing that we learned with solving absolute values is that it's not supposed to have a negative. So really, this is where we can think about it. Absolute value bars get rid of any negative, which means that no matter what, this side is going to be a positive number. Okay? Is a positive number less than negative 6? So is that true or false? Is a positive, any positive number, as little as 1, as big as 1,000. Okay, 1 is less than negative 6. This is false. You cannot have a positive number less than negative 6. So I want to remind you of something. When we were solving systems, when it was false, our answer was no solution. These are actual problems I pulled off of notes that we had, okay? Remember, when it's false, it's no solution, okay? So right away we know that our answer is no solution. Remember, you can write that like this as well. So last but not least, this is the last one I'm doing with y'all at least. Y'all are going to finish. Okay. On this one, we have to get our absolute value bars by themselves. So how do we get rid of a plus 56? We subtract 56. This goes away. I'm left with the absolute value bar of 8x is greater than or equal to, what's 40 minus 56? So what, negative 16? So again, we have a negative. Okay, so when we have a negative, we don't do all of these steps. Okay, so let's think about it. This is any positive number, and it's greater than or equal to negative 16. Is any positive number greater than or equal to negative 16? Yes, so this is true. So again, looking at old stuff, when it was true, it's infinitely many solutions. So it's I MS, or you can write all real numbers. Okay, both of those would work. Okay, so just remember, true means IMS. Another thing that you can remember is that anytime, so this is greater. Okay, anytime it's greater, it's no solution. Oh, just kidding, haha. It's less than. I was like, wait, that doesn't work. Okay, because that's greater too. So this is greater. Don't listen to that, what I just said. This is greater, okay? So anytime it's greater, it's going to be IMS. It's true, okay? Anytime it's, so you don't pay attention to greater or less than until after your absolute value bars are by themselves. So this is actually less than. That's when it'll be false and no solution. Okay, but you can always think about it just this way. All right, so guys, your job is to finish working this whole worksheet out. Okay, you will be turning in your packets to me on Tuesday with your test. Okay, so make sure you're working. Make sure y'all are asking each other questions. I will have an answer key for the substitute to be able to allow you to check your work. Okay, I also will be posting this video on my website with the answer key as well. So here is my website, just to remind you. Y'all have a great weekend. Make good choices, okay? I'll see you on Monday, I promise.